The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
Also wanted to highlight that with CPS as the manufacturer for both the battery and the PCS, meaning the entire system, during the design phase, we actually consider everything from the DC to AC side. So there are like multiple layers of protections, especially from electricity perspective to kind of like you said, any component can fail, but you want them to fail safely. So we have all these, different measures in different steps to make sure that if something's wrong, it won't escape the tent or it will be, contained in there.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, grid scale batteries. I'm Tim Montague. Welcome to the Clean Power Hour. Please check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple or Spotify. Tell a friend about the show. That word of mouth is, frankly, the best thing you can do to spread the word about the Clean Power Hour. And please reach out to me. I love hearing from my listeners. I'm easy to find on LinkedIn, or you can contact me via the website, cleanpowerhour.com. My guest today is Dr. Zhehan Yi. He is the Director of Utility and Battery Energy Storage Products at CPS America. Welcome back to the show, Dr. Z.
Thanks, Tim. Nice to see you again here.
We're going to be geeking out on your grid scale battery solution. You now have a 5 megawatt hour battery solution. And as we were discussing in the pre-show, here in the US, there's a massive explosion of data center development for a variety of reasons, partly because of Bitcoin and partly because of AI, right? Every day I'm using AI now, and that is extra computing power means more data centers. I checked out some statistics. Data centers are growing at more than a 20% annual growth rate. That means we're doubling the number of data centers every 3 to 4 years in the United States right now. So it's massive growth. And that is good news for the clean energy industry, right? Because a lot of those data centers are going to utilize wind, solar, and batteries. And as we were discussing, and this is something we're going to geek out on, is some of these facilities are initially being designed as off-grid to facilitate the timeline. In other words, to accelerate the development cycle. They may eventually get interconnection to the grid, but they want to operate off-grid initially so that they can just come out of the ground and not wait for an interconnection with the utility, which could take 3 years. So, Dr. Z, tell us a little bit. You don't need to give us a bio on yourself because we can point listeners in the show notes to the previous interview that we did where we talked more about your background, but give us a taste of what your responsibilities are at CPS.
So I heads up the product management for the utility, solar, and energy storage. So I work very closely with R&D team for new product developments and also supporting our customer in designing their projects with our utility and energy storage products.
Very well. And what is your take on the utility or grid scale energy storage industry right now in the United States? Just give us a high level perspective from CPS's perspective. What are you seeing?
Well, I'm still seeing, I think, a lot of deployment, and like you said, the booming from the data center and a lot of new applications are needing battery and the PV systems. It's still growing, I think, healthily, and we're seeing a lot of demands from customer side And also the technology has been evolving from the cells or from the chips itself, for example, for the PV inverter, for the battery technologies. So I think everything is like moving faster than what we have been thinking, especially the applications in the US has been booming.
So CPS has rolled out a 5 MWh battery solution. It's a 20-foot container for the battery, and then there's another container, if I'm right. I want you to clarify this, and maybe you can show an image for us at some point during the interview. But there's a 20-foot battery container, and then there's a PCS, which is a power control system. A PCS is like an inverter, but it's bidirectional. So, a solar inverter is converting the solar DC to AC for the grid. And in the case of a battery, the battery is charging from the grid or it's charging from solar, but then it's also discharging to the grid. So anyway, tell us about the 5 MWh solution, why a 5 MWh solution was so important for CPS.
Yeah, so we have this 5 MWh, what we call a power block. We name it power block. And it actually consists of both the DC side and AC side. So the DC side, like you mentioned, is a 5 MWh container. So we pack 5 MWh of battery cells inside a 20 feet high cube container. And we also have another, what we call container, but it's actually open frame, just the same shape as a container. It's the PCS, like it's essentially the inverter plus the MV transformer. So the whole solution is including both the battery, the DC side, and the AC side, the PCS. So like I mentioned, the PCS, it's like a strange concept, but it's nothing different than PV inverter. It's essentially an inverter, but it's for battery and it's bidirectional. The reason why it's called power conditioning or power control system is because it can also work in a grid forming mode, where in the case of a microgrid, it will act as a generator to set up the voltage and the frequency. Where a lot of PV inverter, I think most of the PV inverter don't do that because PV is treated as a non-dispatchable resources, especially at night you don't have PV, right? So by battery, you can condition the SOC, condition the energy management to make it possible to work as a voltage source or frequency source. So that's why I think the reason why it's called a PCS. Essentially, the application is an inverter.
Understood.
And
go ahead.
And the 5 MWh, 2.4 megawatt, what we are using here, it's an important product for the CPS, because I think this is the first product that we are pushing to the US market as a utility energy storage. But I do want to mention that CPS is not new to energy storage. We deploy roughly 2 GWh of battery globally already. So the way we're doing that is we usually verify the product strictly in applications like real field applications before we land the product in the US. So it takes us a little bit longer for the utility battery to hit the US markets.
Yeah, sometimes we forget, Dr. Z, here in the US, because we're such a big country, that there are other markets that are further along in the energy transition, right? Northern Europe and Asia are further along for a variety of reasons. Energy is more expensive in those places, and so there's more incentive to adopt new technology. Now, of course, it is heady days, and we have very rapid growth of both utility, commercial, and residential solar and storage now in the U.S. Attachment rates are going up, and I would love for you to talk a little bit about this phenomenon, though, of data centers and the potential that developers have seen for building off-grid facilities. A 5 MWh battery gives you that possibility, right? When a 100 megawatt data center that needs 24/7 off-grid operation, that's a big solar farm and a big battery. How big a battery do you need to make a solar and storage microgrid that will operate a data center?
Yeah. That's an interesting phenomenon that we're seeing. We're seeing a lot of demands, especially the Southwest, especially Texas, to be honest. A lot of facility for crypto mining or AI data center setting up, which needs microgrid support 24/7. And usually those sites are designed with both PV and energy storage. So during daytime, the PV can charge the battery, and during the nighttime, the battery can support the power or the load for the AI center. And those projects are unique, I would say. It's a little bit different than traditional utility energy storage or PV systems because they want the system to be running 24/7 in a microgrid mode, at least for the first couple of years, I guess, to, like you said, to accelerate the development of the project itself. So that required the inverter itself to have the grid forming capability from PCS, right? So the PCS will have to run if you have like multiple PCS, which in the case it is, right? You have to have a lot of PCS to support that large facility. So the PCS has to run in parallel to support the frequency and the voltage of that grid, the microgrid. And at the same time, it will have to provide a long duration backup during the nighttime. Because, for example, at least like 10 hour, or we're seeing some of them even asking for 12 or 14 hour of backup during the nighttime,
Right.
to support the load. So those projects are pretty unique. Really, they would have what we're seeing right now, probably around range from 10 to 50 megawatt, but asking for 100 of megawatt hours of backup of battery. So it will have a lot of DC block, like battery container, behind the PCS to support this case.
So let me, a quick question there. Let's say you're
Yeah.
designing a 100 megawatt hour system, understanding that the instantaneous demand might be nothing more than 20 megawatts.
Yeah.
So are you saying that you can install 100 megawatt hours of storage, but have a smaller PCS?
Yeah, that's possible. So there are two ways to do that. The first is you can have smaller PCS and you can combine the DC block behind the PCS with the DC combiners and of course some necessary protections inside.
Mm-hmm.
Similar to PV, right? If you string more PV panels or PV strings, then you go to the inverter. You can have a higher DC to AC ratio similar to that. The other way to do that, and which is more often, is customer, they usually want to upsize the PCS as well, because I guess the PCS cost is getting lower and lower, and also because of the fact that in another couple of years, the customer would like the system to be connected to the utility grid. So they are not only using the battery just for backup, like after a couple of years later, if the system is grid connected, then during the nighttime, the battery can be used as a backup for the load. But during the daytime, they can also use the battery to support the grid, like participate in the electricity market,
Mm-hmm.
frequency response, or ancillary service, for example. So there's additional value proposition in there besides just the backup functions.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. Right, yeah, the battery provides a stack of values, and you can especially utilize those during the day when, for example, you might have a capacity day or high demand charges during certain time of use, like the late afternoon. So I love it that developers have found this angle to enable their facilities to operate in microgrid mode or off, and then eventually they can connect when they get permission from the utility to and have full grid connected capability as well. And one of the contexts here that's driving this is energy prices are going up. We've had inflation. We also have the Inflation Reduction Act, the IRA, right, which increased the ITC. We can get up to 60% ITC. This is one of the reasons Texas is so popular. There's a lot of energy communities in Texas. And while we're not stopping to burn oil anytime soon, those are energy communities where they're mining oil out of the ground, and you can put a solar farm or a solar and battery operation on that real estate and get a higher ITC. So that's a good driver in ERCOT. Let's talk a little bit about the architecture and the chemistry. These are things that our listeners are very curious about. Lithium iron phosphate being the most popular chemistry for stationary storage now for a variety of reasons: cost, reliability, low thermal runaway. What is the chemistry that you guys are using, and tell us about the architecture?
Yeah, we're using RFP, and our 5 megawatt hour system is using a 314 ampere hour RFP cell, which is, I think, the latest technology. So CPS was actually the first manufacturer to make a 5 megawatt hour battery into a 20-feet container with a 314. So we were the first to get a UL certification for that back to 2023. And we've deployed actually a lot of this already overseas, and we've been designing a lot of projects in the US as well, including some of those data centers or the crypto mining sites. With respect to regarding the structure itself, we are doing it a little bit different. We're using a string structure, which mimic the PV string structure. So instead of using like a central PCS, like a larger, for example, 2-3 megawatt PCS, to pair with our 5 megawatt hour battery, we're using a PCS skid, which includes 12 of the 200 kW PCS. So each PCS is connecting to one rack of battery, which means you can do rack level management and monitoring and control. So if one of the rack is down, one of the PCS is down, we're just talking about 200 kilowatt instead of a whole block compared to central structure. So I think this won't also make it more appealing for those AI center sites, because is the most important thing that they're looking for, because the system is running 24/7 without a grid, at least for the first couple of years. So you really want redundancy from the PCS to support this case. For example, if some of the PCS module is down, we're just talking about a couple hundred kilowatt down instead of like a 2 or 3 megawatt, which will have a lot of impact on the load side. And also, the string PCS will offer a better uptime in general, because for our system, we are designing the PCS module to be totally swappable, just like the PV inverter. So if one of the PCS module is down, you just take it out. It's quick connector, so it's pretty easy with design, easy for O&M. So just take the module out and then put a new module in, plug in, and that's it. So the whole PCS module is swappable in the field, and you don't have to wait for manufacturer's technician to show up with long lead time items. Sometimes it can take weeks or months. So the customer, their O&M team, they can just do the swap by themselves and then send the failed unit back to us so we can do the analysis or RMA. So I think this will reduce the downtime significantly, especially from an O&M perspective. And also at the same time,
I think this central to string phenomenon that CPS is now well known for is so important from an asset ownership and developer perspective. You have a 20-foot container that when there's a problem, you're just swapping out small pieces of that container. And so two people and a pickup truck can do the repair. And you can easily store extra product on site. And so you're reducing downtime and increasing overall reliability and performance of your asset, which is vital. I had another question though, and this is about safety. So any battery is going to have some level of risk affiliated with it. That's just the nature of the beast. But it's a question of how safe you can get. And increasingly, we want to convince AHJs that the technology we're using as developers and asset owners is not going to be a problem for them and their communities. So talk a little bit about how CPS has approached safety and some of the hoops maybe that you have to jump through to get UL certification.
Yeah. So there is I think the most important safety people worrying about is about fire or thermal runaway. So the battery actually from the design perspective, I think that's the most important thing that we have in mind during the design phase. So we have integrated fire suppression system inside the system. So We have actually two layers of, I would say, the fire suppression system. One's the gas, and the other one we also have built-in water pipes to flush the tank or cool the tank down in case there's a fire. The fire engine can just hook up the water hose directly to the tank and then flush the tank down to keep the temperature down and prevent the fire from coming back again. So we have actually a lot of considerations from the fire suppression system itself. And also when we are designing the system, we also consider the container itself to be fireproof or exposure proof. So we have a 60 minutes, or even we can make it larger or longer duration with custom made material. We currently, the standard product have a 60 minutes firewall inside the container itself to prevent fire from escaping or fire from propagating to another container in case there's something happen. Those are like some of the majors. It's hard to cover all without pictures or all those materials. But the other one is I want to mention we have the UL9540 ready for both the battery and the PCS. So UL9540 is a system level certificate for the battery, not only just covering the DC side, but also the AC side. So it's to ensure the battery is a safety operation with the specific PCS. So in this case, with CPS, we are the manufacturer for both the battery and the PCS, meaning the battery and the energy storage inverter. So we are the manufacturer of the whole system, which we've tested, integrated, verified thoroughly to get the certificates. So I think that's also one of our strengths, because we're the manufacturer of not only the battery, but also the PCS. And actually we cover the whole system, verify the whole system in terms of safety.
Yeah, I think this gives developers and asset owners a lot of peace of mind, because it's quite messy if you're dealing with different manufacturers. One of the approaches in battery storage is for one company to make the battery packs, one company makes the container, one company makes the fire suppression system, and then there's an integrator that's putting it all together and the software, right? In this case, CPS is very analogous to Tesla's approach, right? Where you're designing and building everything end to end. It is a CPS product, soup to nuts, with the exception of the cells, which is true for the vast majority of battery makers in the world. And because it just is going to be a smoother, installation, commissioning, and O&M across the board. One manufacturer, and in this case, CPS, which I recently said on LinkedIn, right? The CPS way is to provide fantastic customer service, and that is one of the major differentiators between CPS and all of your competition, frankly, globally. There's lots of good technology on the market, but it's a both and. You need good technology and great service, because eventually everything breaks or has a technical, or you're going to have a technical question, and you want to be able to reach a human who's going to treat you well and give you the attention that you need and do what they say they're going to do. And unfortunately, that's just not true with so many others. So anything else you want to say about the safety features of this 5 megawatt hour solution? And then maybe we could close with our last couple of minutes here and talk a little bit about looking forward and supply chain, because that's on the minds of most everyone, is what does it take to actually get your hands on these products? But anything else about the safety features you want to highlight?
Yeah, I also wanted to highlight that with CPS as the manufacturer for both the battery and the PCS, meaning the entire system, during the design phase, we actually consider everything from the DC to AC side. So there are like multiple layers of protections, especially from electricity perspective, to kind of like you said, like any component can fail, but you want them to fail safely. So we have all these different measures in different steps to make sure that if something's wrong, it won't escape the tank or it will be contained in there. So if it's from different supplier, it's really hard to guarantee that, because battery is not like PV modules and PV inverter, right? PV module you can buy from anyone, and then inverter from anyone else. They will just work magically, but for battery is very different. You have to know the characteristic of the DC side, the battery itself, the design of PCS, and make sure that the control of PCS can safely control that battery to avoid or to eliminate those failure. So with that perspective, I would say CPS is really good at that, and we have been really good at string structure as well. Especially we have been the number one market share for the three-phase string PV inverter in the States for the last 8 of the 9 years. So string is in our gene, and we only focus on string, and I would say focus is very important because that's how we make it work. That's how why we are good at that.
Very good. So luckily, supply chain woes have gotten better since COVID a couple of years ago, but getting your hands on a 5 megawatt hour battery is completely non-trivial. I'm involved in a 2 megawatt hour project right now here in Illinois, and I think we're looking at 18 months lead time for a Tesla product. And so the fact, again, that you're manufacturing a product that is already shipping globally and now coming to the US is, I think, a bonus for our listeners. But if you were a developer ordering product today, when would you expect delivery on that? And talk a little bit about how the product is moving through the supply chain.
Yeah, so I was a little bit surprised when you said 18 months because our typical lead time for battery is about 6 to 7 months with the battery and the PCS, the turnkey solution, which means battery, PCS, and the medium voltage transformer can wrap in 6 to 7 months through state DDP. So on supply chain, I think we have a really strong partnership with our cell supplier, Qing. CPS is under the public company Qing, and Qing is a company who has a lot of partnership, like strategy partnership with our supplier cells globally. So we have massive of manufacturing facility to support our project in the US. So I think from logistic and also manufacturing point of view, I think we have a lot of advantages over there to make the lead time quicker than most of the product in the markets. And
yeah, Chint Group is a major industrial powerhouse. I think of it as the GE of Asia, and just look it up on Wikipedia. It's a massive international conglomerate, which does give you some advantages when it comes to partnerships. I don't think it's any secret that CATL is the manufacturer of the cells that you're using, right?
yeah, we only use not top one, but like we only use top cells with the best quality. So CATL is one of them.
Okay. So 6-month lead time, you can place orders today. Just talk to your CPS rep, or chintpowersystems.com is the website. But let's talk a little bit about how the product is put together. Are the skids, whether we're talking container or skid in the CPS, in the PCS's case, it's a skid, but the container assembled in Asia, or where is the assembly done? And then how does it move into the US?
Yeah, so both the container for the 5 megawatt hour and the 2.4, right now we are assembling them in China and ship directly to the US to the sites.
Got it. And I would like to remind my listeners that Chint holds a wonderful event in April called Product Innovation Day. Reach out to me if you want to get an invitation to attend that event. There are loads of engineers and EPCs and developers and asset owners who attend this event, and it's just a great way to meet colleagues in the industry. These are solar developers, but also storage developers, obviously, and you get to meet other colleagues, but also get a deep dive into the Chint culture, the CPS America culture there at your headquarters in Dallas. Lovely, lovely event. So reach out to me if you want to get that invitation. And Dr. Z, I'm just curious, is there anything else that we didn't talk about that we should let our listeners know about this 5 megawatt hour battery that Chint is now making?
I think the only other thing I want to mention is we are ready here to support your projects with not only the product, but also our whole team here. So we take care of every project and every of our customers. We have been supporting more than 20,000 projects in the US, and we'll keep doing this to every one of our projects and customers.
And I want to remind our listeners that they can find all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple or Spotify. Reach out to me on LinkedIn. And with that, Dr. Z, how can our listeners find you?
You can find me on LinkedIn, of course, and also shoot me an email or text me in LinkedIn if you have any questions related to the CPS products.
Very good. Well, I'm Tim Montague. Let's grow solar and storage. Take care, Dr. Z.
Yep, take care. Thanks.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.